Alright, so I think I have to fix a bug here. Let me open the tests. The slash. Yeah, okay. So in here, I think the test was regarding if I create a static and then I should write a test for let's say test test resize uh, test um, test overflow, right? How will this handle overflow? Okay. Yes, return. No. Okay, so I have here I create a static a static array, static hash map with size 5. So if I insert test resize expect 4, if I try and insert two more values, okay, so this is 6, this is 5, this is 5, this is 6, this is 5, this is 6, this is 5, this is 6. Okay, so now I will insert two more of these. So I'll go int rc hashmap 5 hashmap 6 5 5 and okay, I just want to insert it. Hash map set failed to set test 6. Okay, now I don't worry about deleting, not worry about displaying. Test overflow, test destroy, destroy right. Okay, and alright. So if I can make huh oh test test overflow was right. Hold up. Alright, so this is here hash map for 6 when it traverses 6 6 6 map test 3 this is 5 5 5 and then this is 6 6 and 6. Okay, so we will make it again. Right, wrong count traverse. Okay, where is traverse? This you're in traverse. Traverse call should be 6. Huh. All tests passed. Bruh. This should be impossible. I set uh, buckets. Okay. So the number of buckets are 5. Right. Okay. So yeah, it can resize itself. That is correct. Okay. So yeah, it won't fail. Yeah, okay. So these are resizable, so it would not fail because the inner lying uh, because the inner lying what the underlying dynamic array resizes itself, so this is good to go, right? Okay, there is no bug here. It is indeed good to go. All right. Yeah, hash map set finds the value, check if it is not found, existing node was found, we create it. Then if we have to resize it, okay, if the load factor is defined, only then we resize it. If the load factor is not defined, we don't resize it and we simply add it in the bucket. Yeah, okay, let me increase entries, and there we go. Okay, great. Alright, so this is done. What else can I do now? Okay, let me just clean it. Right, so then we move on to hash map algorithm. Okay, let me take a look at the book. What should I be doing with these algorithms? Hash map algorithms. Okay. Okay. So hash map, there are three hash functions that is implemented in this exercise. Okay, we've already seen Jenkins hash as a default hash for the hash map data structure. So this exercise will be looking at these three new hash functions. The code for them is usually small and it's not optimized at all. As usual, I'm going for understanding. Okay, the head is very simple. Then we create with this file then has the three hash algorithms. You should notice that I'm just using a B string for the key, but I'm using the bcarry function to get the character from the B string, but returning 0 if that character is outside of string length. Okay, each of these algorithms are found online, so go search for them and read about them. Again, I primarily use Wikipedia, then followed it to other sources. I then have a unit test that tests out each algorithm, but it also tests whether it will distribute well across a number of buckets. Okay, so I have to understand how does the distribution of these buckets work, right? So I have the number of buckets in this code set fairly high since I have a fast enough computer, but if it runs slow, just lower it and num keys. What this test lets me do is run the test and then look at the distribution of keys for each hash function using a bit of analysis with a language called R. Well, I'll be using Python and pandas, but we'll go to that later. I do this by crafting a big list of keys using the gen keys function. These keys are taken out of the dev urandom device and are random byte keys. I then use these keys to have a file distribution function fill up the stats array with those keys would where those keys would hash in a theoretical set of buckets. All this function does is go through all of the keys, do the hash, then do what the hash map would do to find its bucket. Okay. So, alright, so okay, so I would have to do some changes to hash map algorithms, right? Yeah, so I would want the new hash map algos. uh, hash map algos. Okay, so we have um, okay, I'll create a helper function which calls them by okay, so first of all I would go here and delete these guys, then bring in the new hash maps. Oh, okay, so I guess I would bring in everything from here. Hash map algorithms, let's get rid of these things. Okay, so I want to include this murmur3 hash into hashmap algos, right? So I'll create a section for this murmur3 hash. Hashmap murmur3 hash void data and then feed. I think it works like that. Okay, so let's open the file. Right, so there's a okay, so it takes in the length and then the seed, right? And can I open the source file as well? Okay, so we have these values 32. Alright, so number 3 void data, right? Let's generalize it a little bit. Hashmap algos, good data, and then length. Okay, I have defined, let me open hashmap. Right, I have defined this hash function with a seed. So it takes in a key and it takes in a seed. Right. So default hash, I think I might have made some changes to default hash. I don't need this. Yeah, default. Where is the default hash function? Compare default node, default compare, get node, default hash. Okay, there we go. So okay, default hash. So I will update this function to take in a length as well, right? And then let's go default hash st len. I can just pass in the length. Alright, so this is uses this. Okay, first of all, st len seed. I think I'll take a pointer with seed, right? 4 bytes. Yeah. Okay, I can pass in a pointer. Taking a pointer for seed, it will be 4 bytes. Okay. Taking a pointer for seed, and yeah, I can. Yeah, seed. Okay. 32 pointer. If I can just check if it is null, right, then we can use the default value that will be given here. Okay, so you boys are getting a little updated. Nope, I don't want to purchase. Let's copy these values. Alright, and I'll add st len. Okay, so these are the functions. Takes data, it takes in data, seed, alright. So then we have data, len, seed. Okay, so we have this data hash. Okay, so I'll go hash equals we'll go if seed is not null, then if seed is not null, okay, if seed is null, then use this, else use value of seed. Okay, saying if externally seed is provided, then use that, and I can go with len. Okay, fnv prime, constant expression. Alright, so these are in the offset basis. We'll go with size tlen and seed. Okay. Okay, seed doesn't really play any role here because I'm just taking mod with Adler. Okay. DJV hash. This is size tlen seed. Right. Yeah. Okay. I just need to provide seed. Right. It won't really have to do anything. We'll keep it same. Exactly same. Just use the length parameter here. Right. Same here. Same here. Now I have to. Okay. Data length. So this is it. Would have to include these things in here. So helper functions for hash map murmur 3 hash. Right, hash map murmur 3 hash. Then go with this. I think I should include all these. Then we have fix. And then finally we have the function itself. Okay. Right, so I would have to name it to this. Right. Seed pointer. Okay, so I'll go seed equals if seed is null, then use this, else use value of seed. Okay. This is the update, which is if seed is provided, use it, else use 0. Use 0 as the seed. Alright, so I have successfully. Okay, I would need time.h here. Right. Do I use debug? Do I use any of the debug operations? I don't think so. I wouldn't use debug here, though rand function is defined in here stdlib, right? Okay, time.h is used here. I think I will use it here too, though I don't have to worry about yeah, see, okay, cool, so I don't have to care about time and all, because all these seeds, none of these depend on just the time. So hash map, the implementation of hash map should handle the time, which it does. I'm pretty sure it does. Well, yeah. And then we initialize time with, there we go, and then we store the seed. Okay, we store the seed, map seed, and hash map will be initialized once and for that time seed. And when does it call the default hash? I would like to see that. Do we have any references to default hash? No references, no usages. I think it does call it right around, not in here, right. Map, I'll go address of seed, address of seed, and alright, so we pass in, but we also have to pass in the hash map find buckets. Key, where is it being used? Hash map find buckets, where is it? Hash map find bucket here. Okay, key one. Alright, hash map find buckets, hash map find bucket here. So these are all the references. Rehash. Okay, so apparently internally, okay, so I'll rely on these hash functions using, okay, so we'll go with, I will have to update it again. Don't take in the, right, don't take in the length, right. Okay. So forget about length. Alright, forget about length. We are going to cast, don't worry about length. We go b length s, right, yeah. Okay, seed, doesn't really matter what you provide here. Then again, don't worry about length, and here again don't worry about length. Okay, but here const void key length, I can use a helper function, right? This is murmur 3, yeah, okay. Murmur 332, just copy the name, my man. 332, we come in here, we change this, we make it static, and this is unity function, and then I will create this function which can pass in the data, right. How is that passing the data? We go default hash, okay, we take in the data, we pass in the data, and then also pass in the length. Right, I have to update this as well. So we go size G len equals B length. We string it. Right, we'll be passing the length and feet. Okay. So I have to do the same here. Alright, so just I will make a quick change here. So quick change here. And hash map algo. This is the utility function. Then I will store the key equals b data. B data, we will cast it to b string. Size len equals b length b string data. Does this? Do you know about b string? You don't know about b string? Okay, bstrlib.h. You should know about b string. Then we return this murmur3 underscore 32. With key, len and feet. Okay, there we go. I think that's it for today.